What if a tank from the 1930s was already trying to solve problems that engineers would struggle with for decades? Some experts called it the future of armored warfare. Others believed the entire project was doomed from the start. Its technology looked revolutionary. Its performance impressed military observers. Yet one hidden problem threatened to destroy everything. Why did a machine that seemed years ahead of its competitors never achieve success? What secret made Landsverk L-30 one of the most controversial tanks of its era? If you're interested in tanks, secret military projects, and forgotten war machines, be sure to subscribe to the channel and turn on notifications. There are many more fascinating stories ahead. Enjoy the video, and let's continue. Stay until the end, because the final answer may completely change how you see this remarkable machine. In the history of tank development, there are many vehicles that became famous due to their participation in wars, loud victories, or a record number of produced units. However, sometimes projects appear that are almost unknown to the general public, but at the same time turn out to be much more interesting than many famous combat vehicles. One of such projects was the Swedish tank Landsverk L-30, a machine that looked as if it had arrived from the future a few years ahead of its time. The beginning of the 30s was a time when the whole world was trying to understand what a modern tank should be. Military specialists carefully studied the experience of previous conflicts and concluded that existing armored vehicles were far from perfect. Some machines had good cross-country ability but moved too slowly. Others could develop high speed but lost their advantages as soon as they left the road. Engineers from different countries were looking for a solution to this problem, but most projects were merely attempts to improve already existing designs. Against this background, Sweden looked rather unusual. The country did not participate in major military conflicts and could afford to experiment much more boldly than many of its neighbors. While the leading powers focused on the mass production of equipment, Swedish engineers considered the most unexpected ideas. It was then that the Landsverk company turned into one of the main centers for the development of promising combat vehicles in Europe. By the beginning of the 30s, the company's designers had already accumulated significant experience working with armored vehicles. They carefully studied foreign projects, analyzed the strengths and weaknesses of existing machines, and increasingly came to the conclusion that the future of tanks might turn out to be completely different from what most military specialists of that time imagined. In the engineering bureaus, the idea of creating a machine that could combine the advantages of several types of equipment at once was gradually forming. The task looked almost impossible. The new tank had to be fast on the roads, move confidently over difficult terrain, and at the same time maintain full combat capabilities. For the beginning of the 30s, such requirements seemed extremely ambitious. Many specialists believed that an attempt to combine such different characteristics would inevitably lead to serious compromises. But this was precisely the special feature of the Landsverk engineers. They were not going to look for simple solutions. Instead of a gradual improvement of existing machines, the designers decided to take a much more difficult path and actually create a new generation tank. Soon, a project appeared on the drawing boards that made even experienced military experts take a closer look. Its unusual technical solutions looked so bold that some considered them brilliant, while others viewed them as too risky for real application. No one suspected then that this very project would become one of the most unusual experiments in the history of Swedish tank development. But the most surprising thing was not even its armament, armor, or size. The main secret of the future Landsverk L-30 was hidden in a design that practically no one dared to use on such a scale. It was this feature that was supposed to turn the machine into a technical wonder of its time and simultaneously become the cause of all its future problems. When work on the new project was just beginning, the engineers faced a problem that seemed practically insoluble. In those years, tanks constantly faced the same contradiction. For high speed, certain technical solutions were required, while for confident movement over rough terrain, completely different ones were needed. By improving one indicator, the designers almost always worsened another. The military of different countries carefully observed the development of armored vehicles and increasingly demanded the impossible from manufacturers. They needed a machine capable of quickly covering large distances on roads without wearing out the chassis ahead of time, and then entering into action on difficult terrain without preparation. On paper, such a concept looked ideal. In practice, however, no one could offer a genuinely effective solution. It was then that the Landsverk engineers decided to turn their attention to an idea that had already been discussed among specialists for some time. It was the wheel track design. The concept itself was not absolutely new, but until then its capabilities had remained limited, and many projects never managed to prove their effectiveness in real conditions. The Swedish designers saw a much greater potential in this system than most of their colleagues. In their opinion, the tank of the future should not have to choose between speed and cross-country ability. It was obliged to receive both advantages simultaneously. If the machine moves on the road, it uses wheels and develops high speed. If a difficult section of terrain appears ahead, it switches to track drive and maintains the ability to overcome obstacles. It sounded so attractive that the idea quickly received support. However, the deeper the engineers delved into development, the more difficulties arose before them. It was required to create a complex mechanism that would allow the machine to effectively use two different systems of movement at once. Moreover, all this had to be placed within the limited space of the hull without sacrificing the combat qualities of the tank. Each new technical solution gave rise to additional questions. The weight of the structure increased. Maintenance became more complicated. New requirements for the reliability of mechanisms appeared. Nevertheless, the work continued. The designers were confident that in case of success, their machine would be able to seriously outpace most foreign counterparts. Gradually, the project acquired more and more finished outlines. Already at the early stages, it was clear that this was not just about another light tank. The Landsverk L-30 was becoming a kind of demonstration of the engineering capabilities of Swedish industry. The machine was supposed to show that a small country was capable of creating equipment that could compete with the developments of the world's largest powers. As the first calculations and drawings appeared, interest in the project grew. Some specialists began to talk about a real technological breakthrough. Others, on the contrary, warned that excessive complexity could turn a promising machine into a costly experiment. But while the arguments were just gaining momentum, the engineers continued to move forward. Very soon, the project would go beyond the drawing boards and turn into a real combat vehicle. It was then that it would become clear how justified the bold expectations of the creators were. After all, the most unusual feature of the Landsverk L-30 was just preparing to show itself in full. When the first prototype began to take real shape, it became clear that the Landsverk L-30 differed noticeably from most tanks of its time. Even externally, the machine looked unusual. But the main thing was hidden not in the silhouette of the hull or in the armament. The real uniqueness of the project was located much deeper, in the very base of its design. The engineers realized what many considered too complex for practical use. The tank received a full wheel-track system of movement. Unlike conventional machines, which were forced to constantly move on tracks, the new Swedish tank could use two completely different modes of movement depending on the task at hand. On a good road, the machine switched to wheel drive. In this mode, the resistance to movement was significantly reduced and the speed increased. For the military, this looked extremely attractive. A unit could be quickly redeployed over large distances, saving the resource of the tracks and reducing march time. For the beginning of the 30s, such a possibility seemed almost fantastic. When the path went through soft ground, unevenness, or other difficult sections of terrain, the tracks came into play. It was they that provided the necessary traction with the surface and allowed the tank to maintain its cross-country ability where conventional wheeled vehicles quickly lost their advantages. At first glance, the idea looked practically ideal. It seemed that the engineers had found a way to combine the best qualities of two types of equipment at once. The mechanism of transition between the modes of movement made a special impression. For its time, it was a very complex engineering solution. The designers had to create a whole system that allowed the effective use of wheels and tracks within the framework of one machine. Such developments required high manufacturing precision and a serious level of technical production culture. It was not surprising that the project quickly attracted the attention of specialists. In Europe, the search for new ways of developing armored vehicles was closely monitored, and the Swedish development looked very unusual even against the background of the most daring experiments of that period. Many experts began to wonder, perhaps this is how the tanks of the future will look. Interest was also fueled by the declared characteristics. Theoretically, the Landsverk L-30 could provide a speed unavailable to most tracked vehicles of that time. At the same time, it was not supposed to lose the ability to operate off-road. If the engineers' calculations turned out to be correct, Sweden would receive one of the most advanced combat vehicles of the beginning of the 30s. However, it was precisely at this moment that an old problem faced by many revolutionary projects began to manifest itself. On the drawings, everything looked flawless. The calculations inspired optimism. Specialists discussed the prospects of the new technology and built bold forecasts. But the history of the development of armored vehicles had already shown more than once that a huge gulf can lie between an engineering idea and real operation. While a reputation as one of the most unusual tanks in Europe was forming around the Landsverk L-30, its main test lay ahead. The machine had to prove that the complex and expensive concept was capable of working not only in theory, and it was then that the first signs began to appear that reality could turn out to be much more complicated than the most optimistic expectations. The moment came that both the supporters of the project and its numerous critics had been waiting for. After the completion of the main work, the prototype went out for testing. It is here that any promising development faces its main exam. Paper can forgive a lot, but equipment on the test range quickly shows its real capabilities. The first runs aroused interest among all who followed the development of Swedish armored vehicles. The Landsverk L-30 indeed demonstrated qualities that distinguished it favorably among many of its contemporaries. The machine moved confidently on the roads and made the impression of a very modern project. It seemed that the engineers were close to success. However, as the tests became more difficult, features began to appear that could not be fully predicted at the design stage. The more complex the technology became, the more components required constant control. Each additional mechanism created new points of potential failure. For an ordinary tank of that time, this was already a serious factor, and for such an unusual design, the problem became even more noticeable. The attention of specialists was particularly attracted by the wheel track system. It was precisely this that was considered the main advantage of the machine, but at the same time, it turned into a source of additional difficulties. The complex set of mechanisms increased the load on the structure and required more careful maintenance. Any inaccuracy in adjustment could affect the operation of the entire system. Military observers quickly realized that they were facing not just a tank, but a very complex technical system. For experienced engineers, this looked impressive. For the army units that had to maintain the equipment in real conditions, the situation no longer looked so clear-cut. A legitimate question arose: would such a machine be able to maintain its advantages after prolonged operation?
Gradually, it became obvious that high technology has its price. While some specialists admired the engineering boldness of the project, others increasingly turned their attention to the practical side of the matter. The Army needed not only advanced technology, it needed a machine that could be quickly maintained, repaired, and used without involving a large number of specialists. The more data came from the tests, the more actively discussions unfolded around the future of the project. Some considered the arising problems to be natural difficulties of any innovative development. Others believed that the concept itself was too complex for mass application. The debates became more animated because the question of which path the further development of Swedish tanks would take was at stake. Nevertheless, there were moments that made even skeptics reconsider their assessments.
Despite the identified difficulties, the machine continued to demonstrate characteristics unavailable to many competitors. In some aspects, the Landsverk L-30 really looked like next-generation technology. That was why no one was in a hurry to make final conclusions. Yes, problems existed. Yes, the design turned out to be significantly more complex than expected. But, at the same time, the tank showed results that were hard to ignore. And soon, the attention of specialists switched to an indicator that in the beginning of the 30s made an almost equally strong impression as armor or armament. It was about speed, which became one of the most discussed features of the Landsverk L-30. In the beginning of the 30s, the speed of a tank was perceived completely differently than today. Most combat vehicles of that time moved relatively slowly, especially during long marches. Therefore, each new project capable of significantly increasing the mobility of troops automatically attracted the attention of military specialists. It was here that the Landsverk L-30 began to reveal one of its strongest sides. During the tests, the machine demonstrated indicators that looked very impressive for its era. The use of wheel drive allowed a significant increase in the speed of movement on roads. For the armies of that time, this meant an opportunity to faster redeploy units between different sectors, shorten march times, and more effectively use equipment over long distances. It was particularly important that such results were achieved not at the expense of completely abandoning the tracks. Most fast machines of that period faced serious limitations as soon as they left the roads. The Landsverk L-30 offered a different approach. On routes with good surface, it used the advantages of the wheel scheme, and if necessary, it could switch to track drive, maintaining the ability to operate on difficult terrain. Such versatility made a strong impression. many specialists considered it as a possible path for the development of armored vehicles of the future. In those years, no one could yet say exactly what a tank would become in 10 or 20 years. Therefore, each new technology was carefully studied, and any successful experiment received serious attention from the military departments. Interest in the project was also fueled by the fact that Sweden did not belong to the number of the largest military powers in the world. From it, the appearance of such unusual technical solutions was rarely expected. All the more surprising was the fact that it was Swedish engineers who created a machine that made people talk about it far beyond the borders of their own country.
Even some foreign specialists noted that the developers managed to achieve an impressive combination of characteristics. High speed was always considered one of the most desired qualities of military equipment. It gave an opportunity to faster react to changes in the situation, occupy advantageous positions, and more effectively use available forces. Against the background of many contemporaries, the Landsverk L-30 looked very promising. As the speed capabilities of the machine aroused more admiration, another question arose more frequently. What exactly had to be paid for such results? The history of technology had repeatedly shown that outstanding characteristics are rarely obtained for free. Behind each advantage, certain compromises are usually hidden, which become noticeable only after some time. This was precisely what the specialists who carefully studied the test results gradually began to understand. Yes, the tank could surprise with its mobility. Yes, its design contained solutions that were ahead of many developments of its time. However, behind the impressive figures, a problem was hidden that was capable of cancelling out a large part of the project's advantages. While the public and military experts discussed the speed and unusual design of the machine, engineers increasingly faced questions of reliability, cost of operation, and general practicality. And soon, it was these factors that began to play a much more important role than any record indicators on the test range. The longer the testing and analysis of the results continued, the clearer the understanding of one important thing became. The main problem of the Landsverk L-30 did not lie at all in a lack of speed, not in weak mobility, and not in the absence of promising technologies. On the contrary, the machine possessed many qualities that aroused sincere respect among specialists.
The difficulty was hidden in something else. Behind the impressive capabilities stood an extremely complex design. Each new mechanism added to increase the versatility of the tank inevitably complicated the whole system as a whole. The wheel track scheme looked magnificent in theory and demonstrated real advantages in practice. However, it required a large number of parts, components, and connections. All this increased the load on the machine and made its maintenance significantly more labor-intensive compared to traditional tanks of that period. For engineers, such complexity was proof of the high technical level of the project. For the army, the situation looked different. The military always evaluates equipment not only by its characteristics, but also by its ability to perform tasks over a long period of time. Even the most modern machine loses its value if its operation requires too much resource, time, and qualified personnel.
Gradually, specialists began to compare the advantages of the Landsverk L-30 with the efforts that would be required for its mass introduction. Questions arose about the cost of production, the complexity of repair, and reliability under conditions of intensive operation. If individual components failed, their replacement could turn out to be significantly more complicated than in traditional samples of armored vehicles. In addition, the development of tanks in the world did not stand still. While Swedish engineers were perfecting the unusual wheel track concept, designers of other countries were looking for simpler ways to solve the same tasks. New engines were becoming more powerful. Suspensions were improving. Tracked machines were gradually increasing their speed, without the need to resort to such complex technical schemes. It was here that the Landsverk L-30 began to lose part of its main advantage.
What, until recently, seemed a revolutionary solution was gradually facing competition from simpler and more practical designs. The military closely observed this trend and increasingly wondered whether it was worth maintaining such a complex system if similar results could be achieved in less risky ways. With each new analysis, it became obvious that the fate of the project was changing. No one denied the engineering value of the machine. No one argued with the fact that Swedish specialists demonstrated a high level of skill. However, there is a huge difference between an interesting experiment and a mass military sample. It was at this stage that the Landsverk L-30 increasingly began to be perceived as an outstanding technical experience and not as the future basis of the tank forces. The most curious thing was that the project did not fail in the usual sense of the word. It did not turn out to be useless. It did not prove the fallacy of its concept completely.
Rather, the machine became a victim of its own time. Technologies had not yet reached the level at which such a complex scheme could reveal its full potential without serious compromises. While discussions around the Landsverk L-30 continued, new projects and new approaches to the development of armored vehicles were already appearing on the horizon. It was they that were to definitively determine what place the unusual Swedish tank would take in history, and why its prospects gradually began to yield to more practical competitors. While specialists were discussing the strengths and weaknesses of the Landsverk L-30, global tank construction continued to develop rapidly. The beginning of the 30s became a period of a genuine technical race. Designers of different countries experimented with suspensions, engines, transmissions, and armor schemes. Each new project promised to solve the problems of the previous generation of machines.
Against this background, the advantages of the wheel track scheme gradually ceased to look as convincing as before. Engineers succeeded more and more in increasing the speed of conventional tracked tanks. Engines improved, chassis were perfected, and the general reliability of technology grew. What until recently required a complex combined design was now increasingly achieved by simpler means. The military closely followed these changes. For them, the question of choice always boiled down to practical benefit. If two machines are capable of performing similar tasks, preference is usually given to the one that is simpler in production, maintenance, and operation. It was here that the Landsverk L-30 found itself in a difficult position. Even its supporters were forced to admit an obvious fact. The tank, indeed, offered interesting possibilities, but the price of these advantages remained too high. The complexity of the design meant extra expenses, increased requirements for maintenance, and the more serious dependence on the technical condition of the machine. Under conditions of limited military budgets, such factors played a decisive role. Gradually, it became clear that the future of armored vehicles was developing in another direction. Armies needed reliable, effective, and relatively simple machines that could be produced in large series. The concept of the Landsverk L-30 looked too complex for such a role. As a result, the project never received the development that its creators had counted on. However, it would be a big mistake to consider this story a defeat. In fact, many achievements of the project turned out to be significantly more important than it might seem at first glance. Despite the absence of mass production, the experience gained during the development and testing of the machine became a most valuable contribution to the development of Swedish tank construction. Engineers received a huge amount of information about the behavior of complex chassis systems, load distribution, the interaction of various mechanisms, and the features of operating promising armored vehicles. All this became a kind of school for subsequent generations of designers. The mistakes identified during the work on the Landsverk L-30 made it possible to avoid a multitude of problems in future projects. The Landsverk company continued to develop the armored direction and soon presented new machines in which the knowledge accumulated during the work on the unusual experimental tank was used. Many technical solutions, design methods, and engineering approaches found application in subsequent developments. Thus, even without becoming a mass combat vehicle, the Landsverk L-30 continued to influence the development of technology for many years to come. Over time, this tank turned into a kind of symbol of engineering boldness. It reminded that progress rarely moves in a straight line. Sometimes, it is precisely the most risky and controversial projects that help to take the next step forward. Without such experiments, many technologies simply would not have appeared, or would have appeared significantly later. That is why, decades later, interest in the Landsverk L-30 has not disappeared. Historics, researchers, and lovers of armored vehicles continue to return to this machine again and again. Some call it a brilliant example of how a small country was able to offer the world a genuinely original idea. Others consider the project a technical dead end that turned out to be too complex for its time. Disputes do not stop until now. Was the Landsverk L-30 a revolutionary machine ahead of its era, or was its concept initially doomed to limited application? There is no unambiguous answer to this question. Too much depends on the angle from which one looks at the history of this tank. If one evaluates the project by the number of produced machines or its influence on the armament of armies, the result may seem rather modest. But if one considers it as an engineering experiment that expanded the ideas about the capabilities of armored vehicles, the picture becomes completely different. In this case, the Landsverk L-30 looks like one of the boldest projects of its time. Perhaps, had such a machine appeared a few years later, with more developed technologies and other production capabilities, its fate would have turned out completely differently. But history does not know the subjunctive mood. The tank appeared exactly when it appeared and faced exactly those challenges that determined its further fate. Today, the Landsverk L-30 remains a reminder of a time when engineers were not yet afraid to set almost impossible tasks before themselves. It did not change the world of tanks as its creators had expected. It did not become a mass sample and did not turn into the basis of the tank forces. But it succeeded in something else. It proved that a bold engineering thought is capable of looking far beyond the horizon of conventional solutions. That is why the history of the Landsverk L-30 continues to arouse interest after many decades. This is a story of not just a tank. This is a story of an idea that tried to get ahead of its time, showing the world what the future of armored vehicles could be.